Hi guys, welcome to our first lecture, and this lecture talks about the term statistics. And so we define statistics as a pool of techniques, procedures, or methods that can be used to extract meaningful information out of raw data. And this information will be used as evidence for any decisions that we would like to make. So you can see that it's very important to get data, and then we will apply techniques. We do the analysis and get information, and then finally we make decisions. So it's very important for us to start understanding data. So we can define data as information which is collected for current analysis or for future reference. And so data can be anything, or information can be anything, including few as we have shared here, like there can be sales, revenue, profits, population, and so forth. Now, what are the sources of data? We can get data from two sources. One is primary data, and second is secondary data. Primary data is the data which is collected for the first time, and secondary data is data which has been collected and organized. And so primary data can be collected by surveys, observations, experiments, and so forth, while secondary data can be obtained from different sources, including internet, website, organizational records, published sources, and so forth. Now, in this class, we'll be talking much about data distribution or data set. So it's good to define or to understand what is data distribution. So when we have data set, data can be of a certain distribution. So we can say that data is organized according to, probably it can be organized according to gender, or according to cells, or according to any kind of situation. And so that's what it means by data distribution. So if I can repeat again, data can be organized according to, so it can be according to age, according to departments, according to gender, according to many situations. For instance, we can look at this kind of data set, and we can see that this data is organized in terms of age, where we have individuals and we have their age. Then data can be organized according to gender. So you can see we have male and female, or we can have data organized according to years of education or years of experience. And also data can be organized according to salary. So these are the number of data distributions. So we need to organize data if it's not organized. And normally we can organize our data in tabular form. And so you can see this data is well organized in this particular table. And we can organize data by using pivot table, or we can organize data according to ascending or descending order. There are many ways that we can organize our data as long as it can make some meaning. So in this data, you can see that we have fields or variables. Age, gender, years of education, years of experience, and salary are actually variables, or we can say they are fields. And these individuals are observed according to these fields. For instance, if you take Mr. Sean, we can observe his age, gender, years of education, and years of experience, and in fact, his salary. So these are the observations. So now let's look at the number of characteristics of data. And We know normally that data can be either quantitative or qualitative. In other words, we can say that data can be numerical or non-numerical. So for the numerical data, which sometimes they call it quantitative, you can see that data is expressed with digits. So you can see we have 0, 1, 2, 3, 4, and these are integers. And also, numerical data can be on decimal points. So we can see we have 0.23 or any decimal points. And still, this is numerical data. But non-numerical data is the kind of data that is not in numeral, and it's data which can be in words, letters, or categories. So let's say we are talking about countries. So they are not numerals, but they are names. We have A, B, C, D. These are words. Also, we may have data organized into a category. So we may have data organized in category from 1 to 10, 10 to 20, 20 to 30. And so in this case, we have 3 categories of data, and therefore we can say this is not, again, numerical, but non-numerical. So the difference between the two is how to analyze them. The way we analyze numerical data may be different from the way we can analyze non-numerical data. For instance, if we want to analyze non-numerical data or to summarize non-numerical data, all we can do is just to count. For instance, if we have number of countries, all we can do is to count how many countries are there. If you look at the categories here, we can count how many of them we have. So we have 1, 2, and 3. However, if we have numerical data, we will use different measures. For instance, in this case, we can add. Let's say we take 0 plus 1 plus 2 plus 3 plus 4, and then we can get the answer. Something which we cannot do with the non-numerical data. So we'll see, as we move on, we're going to see how we can analyze non-numerical data versus numerical data. And therefore, it's important to differentiate between the two so that we can come up with ways to analyze them. So let's start talking about numerical data. Now, with numerical data, we have actually 2 types. We have discrete and continuous. So discrete values are the ones that are in a form of integers. So if you look at this example, we have 0, 1, 2, 3, 4. So those are integers. They are full numbers. So if we are looking at the number of children, for instance, we may not have a child and a half, but that is discrete. We have 1, 2, 3 children or 0 children. We have 0 or 1, 2, 3 number of children. Number of cars as well. We cannot have a car and a half, and same with number of houses. So these are discrete values. Then we have continuous values which have decimals. Anything that can have decimals like temperature, heights, and distance are continuous. So it's important to differentiate between discrete and continuous values because measurements or statistical tools that we can use to analyze discrete and continuous can be different. For instance, if we are to provide probability to discrete values, we can actually assign a probability to a particular value. Let's say we're looking at the number of children, and we know that there are some possibilities of having from 0 to 4 children. So we can find the possibility of not having a child or possibilities of having 1 child, 2 children, 3, and 4. So we can assign probability to each of them. However, when it comes to continuous values, we cannot assign probability to a particular value because we cannot count decimal points. So we can have uncountable values from 0 to 1 if we are considering decimal points. And because of that, we cannot assign probability to a particular value. And so for continuous variables, all we can do is to find, we can use different statistical technique to assign probability, for instance, cumulative probability, or we can use a normal distribution approach to deal with the continuous values, while when we have integers, we can use discrete methods of providing probability. So it is important to know the difference between discrete and continuous values, or discrete and continuous numerical values. So your values can be discrete or continuous, but also we may need to find out if the data we have is observed or estimated. Observed values are the values which are already collected, and all we need to do is to analyze them. And so in this case, we can use descriptive statistics. We can describe the data which we have on hand. However, if we have estimated values, or we have to estimate values, we will not be able to use same approach, but in this case we will use predictive techniques to predict data. So it is important to understand if your data is observed or estimated, so that you can do the analysis. Now, your data can be observed or can be estimated, but also we need to find out if we have big data or a sample. The difference between the two is techniques that we can use for big data are different from the techniques that we can use for a sample data or a small data. For instance, for the big data, if we have data that is normally distributed, we can use z-test for the big data, but if we have small or sample data, we will use t-test. We are going to see those kind of techniques as we move on. So it's important to understand if your data is considered big data or a small data, so that you can know what statistical techniques you can apply in your analysis. So your data can be big or can be small. However, we need to know if it is cross-sectional or time series, so that we can apply appropriate statistical techniques to analyze them. Cross-sectional data is the kind of data which is collected at the same period of time. Let's say if we are looking at somebody's salary at this time, that is cross-sectional data. But if we are looking at somebody's salaries over time for a certain period of time, then we can see that that is a historical data, and so we call it time series. Now, if your data is cross-sectional, then we can apply some statistical techniques that can be applied only to cross-sectional data. And if your data is time series, then we can apply statistical techniques that can be applied for the time series data. For instance, if we have to deal with the time series data, we have to look at the pattern and just look at the way data performs over a period of time, and so we can do some estimations. However, if our data is cross-sectional, then we can address that particular data at one time. Let's say we can use things like measures of the center, measures of variation, and so forth. So it's important to look at this cross-section, to look at the data to understand if it's cross-sectional or if it is time series. In this class, we're going to deal with cross-sectional data, and then later we'll deal with time series data. So your data can be cross-sectional or time series, but also we need to find out if data is normally distributed or if it has other distribution. When we say other distributions, it means your data can skew to the left or to the right. And so that is different from the normally distributed data. If you understand the bell-shaped curve, that actually represents the normally distributed data. Data without much of the outliers. And so when your data is normally distributed, we can use some statistical techniques that are based of the normal distribution. For instance, z-test or t-test. But if data skews to the right or to the left, so we can use other kind of statistical techniques or analysis. For instance, we can use chi-square or f-ratio. So it is also important to understand if your data is normally distributed or other distribution. In class, I'll be mentioning that assume our data is normally distributed, and so I'll ask you some questions. So that means when I said assume our data is normally distributed, it means that we want the data to be normally distributed so we can apply statistical techniques and analysis that are based on the normally distributed data. And if it's not, then we use other kind of statistical analysis that will deal with data which is skewed. So that's all for now about the numerical data. And so let's look at non-numerical data. With the non-numerical data, we can find if our data is nominal or if it's ordinal. Nominal data is the data that has no natural ordering. For instance, if you have to look at the names of people, this can be mentioned in a no order. You can start with the way you want. However, sometimes we can order the names according to alphabet, and so now they become ordinal, meaning that data is now ordered. We put data in a certain order. So whenever we need to put data in a certain order, or if we want to organize names in a certain order, so we call it ordinal. If we don't have to do that, then that is nominal. So take an example, education levels. We have first degree, second and third degrees. So when you put all this together, you can see that we will follow the order because it makes sense if we go with that order, first, second, and third degree, or third, second, and first. So sometimes we may prioritize things, or we put things in a ranking order. That also is an ordinal. But if not, then values will be nominal. Data can be non-numerical, and it can be nominal or ordinal, but also we may have small data that we can use to infer big data. But we can also have big data, which is non-numerical. So it's important to understand if your data is small or big in the analysis. And so that's all for now in understanding the characteristics of data. And I'll advise you to review this and be able to understand your data, to know that if your data is numerical or non-numerical. And if it's numerical, then you have to find out if it's discrete or it is continuous, if it's big data or small data, if it's continuous, if it's large or small, and so on, as we have seen. Once you understand these characteristics, then you'll be able to deal with data. And once data is in front of you, it's good to see and understand it. And in that case, you'll be able to come up with the proper statistical techniques or proper analysis of that kind of data. So thank you.